Okay, no questions about what we're doing?
No.
Everybody good on this? Okay.
Follow my
No.
I think she's got it, yeah. Just follow along, correct your work as you go, and then I'm going to ask you to score yourself after each problem. All right, and remember, the score that I record is not going to be the score you gave yourself. It's going to be a score based on participation and whether or not you gave yourself an honest assessment, right? If you're giving yourself a plus 10 for a problem that you didn't get right, I'm like, what's the deal here? -1, right? But if you got a problem completely wrong and you're like, well, I only knew maybe a third of that, so I give myself a +3. You get full points for that. You see what I mean? So if you're honest about it and you're giving yourself an honest score, you get full points. Tessa?
So the whole thing is out of 10.
I think it's maybe out of 11. Well, each problem is out of 10. Right? And the whole thing is a homework assignment, so it'll be worth 10 points. Okay? I can't say what each problem is necessarily worth. I'm just going to take a look. I'm not going to be a big stickler about it, but if it's obvious that somebody was just winging it, you're not going to get a high score. But if you're actually here and you're trying, even if you didn't get the problem at all, I want you to write down step by step what I've done, and you can still get credit for that. That's okay if you couldn't figure out the problem. I'm going to give them back to you today. Yeah, I want you guys to be able to use these for a study guide, so I'm just going to take a quick look at them today while you're able to work on, your next assignment, even though it's not an assignment, and then I'll give them back, okay? It'll take me like 10 minutes.
So, when you're entering that,
Yes, that will be your last assignment.
so what if you gave yourself an honest to God 10 and you thought that they had an honest to God 10? What do you do then? Do you just put a 10 next to a 10?
I think it's almost clear that you're going to get points. If you got it right and you gave yourself a 10, clearly there's not going to be anything wrong with that, right?
You said that you wouldn't give the same score as, I'm sorry.
You're messing with me now. Okay, that's enough instruction. I think you guys can figure it out. All right, so let's start with the first problem. So this is solving systems of equations by graphing. To start with this, we just highlight each equation, graph it, and check to see where they intersect, right? A good equation to keep in mind when you're doing this, or a good formula, is y equals mx plus b, right? This is from chapters long past. Your y int is equal to the point 0b, and your slope is equal to m. All right, so if I want to graph this first one, I can see that my y-intercept is going to be at the point 0, 2. So I'm going to go ahead and make that point. And then I'm going to look at my slope. My slope is a 3, so I'm going to start at that point I just made, and I'm going to mark off a 3 slope. Yeah, up 3
Over 1.
over 1.
You got that right there. And now go down.
Now we're going to
Okay.
make that awesome line there. We're going to make a sweet line. All right. So this next one.
-2.
Yeah, our y-intercept is at the point 0, -2.
And over 2.
Down,
-2.
-2, because it's -2, down 2.
Over 1.
And so I'm going to go up 2, and it's the same either way. Like, it doesn't matter which way you go, but I'm going to go up 2 because that's where I know my intersection's at, right? If I start going downwards, my next point's going to be down here somewhere. I want my next point to be up by where the intersection's going to
Up
be.
2.
Either way is correct, though. All right, so up 1, 2, and then I'm going to go 1 in the negative direction, and it's that point right there.
I came up with like 3/4 0, so.
I know, I think me and Deja did this earlier and we came up with something different too. But like I said, when it comes to the graphing, it's just important that you graph both lines and that you circle that intersection and you estimate the point. If you're off on the point, it's not a big deal, unless you're like 10 off,
So-
right? Like if you're within 2 or 3 units, it's gonna be fine.
I'm going to give myself 10.
Yeah, so with this one, I don't know, I'm gonna call this -1, 0. Right? If I'm within a couple units, I'm good. The important thing is really that you know how to graph these two equations and you know what it means to have a solution point.
Yeah, you're good.
Now, real quick,
I have my reason.
what happens if your graph looks like this and you have parallel lines?
You did something wrong.
No? Huh? Well, no, I'm sorry. I didn't mean on this particular problem, but what if we have a different graphing problem, and this is what your graph looks like? Nope.
Or
No solution.
No solutions,
There's
right?
no crossing.
A solution happens when they cross. Since these never cross, there's no solutions.
What happens if it lies on top of the line?
I don't know why I'm drawing a circle there. So suppose we graph a line, just like Kev was saying, on top of another line, right? What if there's the same line? Then what is
Then it's
it?
infinite.
Infinite solutions, right? Those are the only two variations on a graphing problem. All right. Huh?
It's projector.
I like it.
Yeah, I think it's the projector or something. Okay, so this was an interesting one, and this one I actually, when I was helping you guys out, I even got fooled on this a couple times. So right off the bat, we're like, well, do we use substitution? Do we use elimination? And I purposely did this. I just put the y's in different order, so they weren't right on top of each other. So it wasn't obvious that they were already additive opposites, right? But if you look at these, 2 minus 2y, those are additive opposites. So we really didn't have to do any initial work on this. If you did, that's okay. It's okay not to do this right off the bat as long as you did everything else correctly. So I'm going to add vertically, right? My 2y's cancel each other out. And then I have x minus 3x. That gives me negative 2x. And that's equal to 5 plus 1, which is 6. Now I divide both sides by the negative 2x. The negative 2.
Negative 2's crossed out.
I get 8.
Right? These guys cross out, and we get negative 3. Right? And so if x is equal to negative 3, I'm going to go ahead and plug that into this upper equation. So I have negative 3 minus 2y equals 5. I'm going to add this negative 3 to both sides. Right? And I'm doing that because I want to isolate this y eventually. So I sort of deconstruct what's around it. So I add 3 to both sides. Boom. And then I have negative 2y equals 5 plus 3, which is 8. All right, now that I only have a coefficient attached to my variable, now it's time to divide,
Y equals
right?
4.
Remember, if you have your variable added or subtracted to anything on the same time, it's not time to divide yet. It's only time to divide at this point. Minus 2, minus 2,
2's crossed out.
and we have y equals negative 4.
Yep.
All right, so
Negative 13. I got 13 for my x. I don't know why, but I just saw it. So how would I grade that if I have 13, negative 4?
oh, good. Oh, that's right. I forgot to tell you guys how to grade these. So typically how I try to grade is if you gave it an honest attempt, I give you 1 to 2 points, and that's it. If you made it through the first couple of steps, I typically give you a 4 to a 5. If you made it through all the steps, but you messed some stuff up, if you messed 2 or 3 things up, you still might be at a 5. If you only messed 2 things up, maybe a 6. If you only messed 1 thing up, maybe a 7. If that one thing is just a small brain fart mistake, you get a 9 or a 10.
Well,
Probably a 9 on this just to be
I get
safe.
7 points. I'm being honest.
Yeah, and it's just, yeah. I try and honestly gauge how you guys do the problems, and I try and keep my grading consistent from student to student, except for Kevin. All right, so go ahead and give yourself a score on that.
7 points.
All right, and we shall move on. Oh, yay. Okay, so just a quick reminder about the 2 word problems that were in here.
Yeah.
So the word problems that were in here, they're still systems of equations problems, and they still did appear in these chapters, but these are probably not the ones you're going to see on the exam. These will be on the final exam, so these are all still good practice. But if you really want to study the ones that are going to be more on this exam, it'll be the mixture problems that we did yesterday. So I apologize for that. These 2 problems sort of made their way in there, and one of these should be a mixture problem. But nonetheless, they are systems of equations, and so these are the kind of problems that you'll see on the final, and possibly on this next exam too. So with these guys, we're always going to have 2 equations, so we need to read these problems, and we need to just pick out where those 2 equations are in the text. First sentence is usually the first equation. The state of Colorado is roughly the shape of a rectangle whose perimeter is 1,300 miles. All we need to do to create our first equation is come up with the equation for perimeter. What's the equation for perimeter?
2L plus 2W equals P.
Right.
Which is 1,300 miles.
Right? And if you're on a test and you're like, darn it, I forgot that equation, draw yourself a rectangle, right? Label the sides, add them up, and figure it out, right? You're like, oh, W and W, L and L. Obviously, if you want the length around this, you're going to have to add all those together. So, 2W plus 2L equals 1,300 miles. I would suggest coming up with a manner to write your L's so that they're easily recognizable. Sometimes people write, I write my L's when I'm not working in math as just a straight line, and that gets confusing. I mistake it for a 1, and you don't want yourself to do that, so make sure you make them distinct. Okay, so now the next sentence, this says the width is 100 miles less than the length.
W equals L minus 110.
Good. L minus 110. All right, so this looks like a good system of equations to solve with substitution. Is everybody clear that there are 2 methods to solve systems of equations?
Because you can do it either way.
Okay, this is a good thing. If you guys aren't sure what to do when you see a system of equations like this, you might want to write on the side of your page 2 methods of solution: substitution and elimination. Right? If you see a system of equations and you have no idea what to do, you need to write that down and study it, okay? You shouldn't freeze when you see these. Kev, are you all right, dude? It's okay. It's participation. Remember, pal?
Yeah.
All right.
I'm right there with you.
So since the variable W is already solved here, I might as well use substitution on this one. So what I do is I plug that W in the upper equation here. I'm going to go ahead and write it
L plus
below.
2.
Right. And
L
Parentheses,
minus
L
110.
minus 110.
We got this.
good. So where the W used to be, I substitute
Equals 30.
L minus 110.
So that'll be good.
Now I gotta get rid of my parentheses, right? You can't really solve much with these parentheses here.
2 into there.
Good. That gives me 2L minus 220
2L
plus 2L equals.
1,300 minus 20. Is that right?
Okay, so, you know, and if you guys are getting stuck like on these equations, it's not that big of a deal because we haven't seen this stuff in a while, okay? And so if you get to this point, we've been solving all sorts of different equations. Some of them are second degree, some of them are first degree. They solve different ways. You know, if you're rough on this stuff, dude, you got to practice because this is going to be everywhere. In the next test and in the final, you know, you got to be comfortable with solving these and the kind with that are second degree. Okay, so just go back to you know, the first. I think it's just chapter 2 that like the initial equations are in.
Yeah.
Work on those. Yeah. You got to know exactly what to do when you get to this point. Okay, so
Like term.
at this point, exactly, we combine like terms. This and this are like terms. 2L plus another 2L,
That is 4L.
4L minus 220 equals 1,300.
Then you're gonna
You wanna get the 220 out of there.
plus 220 on
Good.
both sides.
Plus 220 plus 220. Bam.
1520.
1520. And then I have my L attached to 4 through
So
multiplication.
divide by
Right.
4,
So I divide it out. And what does this give me?
380.
380. L equals 380. So now I'm going to calculate W real quick. So W is equal to L minus 110. So that's 380 minus 110. And that gives me 270. Good. All right. So we have a length of 380 and a width of 270.
And I get 10. Oops.
Okay, go ahead. Give yourself a little score on that one.
Uh-oh. Uh-oh.
He was gonna try to cheat. He tried
I
to.
took my pencil away.
He did. I took his pencil.
Oh yeah, I haven't been looking. Not like you guys are gonna. I'm sure I like look back. Somebody's got their pen. They're all scribbling it out. No, I want to give myself a 10. All right, moving on. So here's the same type of problem, right? This is not really a total value or a mixture problem, the ones that we've been studying. These are sort of a rewind a little bit. So we have Maple Branch Bakers. They are selling 175 loaves of bread each day. Some of these are white, some of them, the rest are whole wheat. Because of a regular order, Maple Branch consistently bakes 9 more loaves of white bread than whole wheat. How many loaves of each type of bread do they bake? So, let's see now, white and whole wheat. So the first one, we're just going to say white will be represented by X, and
Is Y.
whole wheat will be represented by Y. Okay?
So Y equals.
X plus Y equals 175, because that's the total number of loaves, right? And so we need to pick out our next equation from this
So
sentence.
X plus
Why?
parentheses X minus 9.
So X equals, right?
Oh, yeah.
Yeah,
Y plus. Y
Good.
plus 9.
Y plus 9.
Yeah.
Okay, so we might be tempted to use substitution here. Well, no, that's a great way to go about this. Actually, it would be just fine. But I'm just going to show you a little trick. If you don't like substitution,
We like elimination.
notice this real quick. I can rewrite this lower equation, x equals y plus 9.
With X plus 1.
I can just subtract y from both sides. And so I have x minus y equals 9. And I'm already set up for an elimination. Right?
Yeah.
Boom, get rid of those. I have 2x equals 175 plus 9, which is 184.
Sorry.
We have 184.
184, divide both sides by 2. What does that give me? Come on, guys. Let's see, no, 92. Yeah, there we go, 92. I didn't want to think about that one.
92 and Y equals 83.
And y equals,
So 92 minus 9.
Yes,
x was x minus.
yes, that's correct.
I'm sorry, what did you say y was?
83.
83 it is. I will.
I have the exact same numbers, but
Because Y.
I have 92 and 83, but I had X is 83 and Y is 92.
That's
Well, you
totally
could have
okay.
represented them differently
Yeah.
than he did.
That's totally okay. And that, you know, like, yeah, you could have started out by saying whole wheat is y, white is, no, whole wheat is x, white is y. Yeah. It's, when it comes to the bottom of those kind, you know, if you get the two right numbers, it's very rare I'm going to mark you anything off
92 white
just because you've mixed up the two.
Nice.
All right, moving on. Give yourself a score.
Oh,
Honest score of not cheating.
I get 2 points.
Here's another mistake. If you guys will notice, this is the exact same one that I gave you yesterday.
This is
Dun, dun, dun.
Right, and so yesterday we combined these first, and we realized that was kind of a waste of time. So I'm going to split up this 40 into a perfect square and whatever's left.
120.
So 4 times root 10 times root 3.
Oh, see?
Okay? The 4 is a perfect square, so that pulls out and creates a 2.
2.
What I have left is 10 times 3 under the root.
30.
Yeah, root 30 doesn't have any perfect squares included in it, so we can't really, we can't reduce it
I went the
anymore.
other way.
Hey, you like.
I expanded.
Expand.
I have root 120.
All right, give yourself an honest score.
That's cool.
Read the directions.
I'm gonna give myself an honest score. I want to give myself a 10.
1.
Did we do this yesterday?
Well, you know what? I didn't want to do that then.
No, because you were too busy reading your other notes.
Okay, problem 6. So, problem 6, I had a couple of different problems, all dividing radicals. This first one, you know, we just wanted to simplify it as much as possible. Yeah, exactly. To simplify it, we extend the square root over the entire problem, 55 over 5, and then we simplify the fraction in the middle, and that gives us root 11. 11's prime, so obviously it's not a perfect square,
Obviously.
clearly. I'm bad at that. Now that I said that a couple days ago, I realize I say that way too often.
Clearly. Nonetheless. So 9 is
Let's
root
see.
9
Oh, that's right. So
over
with,
49.
yeah, with this one,
Separate it.
you're right. You'll notice they're both perfect squares, so we want to separate the radicals and simplify.
So root 9
That'd be
over root 49.
Yeah,
Yeah, two.
And then
Three
root
sevenths.
7.
3 sevenths.
Right there. Yeah. Woo. Bring it home.
Okay, so with this one, huh?
Then
Oh, you want me to go back?
Honestly, just saying. Really.
The first one,
Copy from later.
Sorry, if I'm going too fast, you guys let me know and I'll slow down, okay?
I actually multiplied the second one.
Okay, so it's definitely a division.
The directions say division right there.
Yeah, and typically, like, when you see these with radicals, like, you just want to simplify it as much as possible, you know? There's no, like, solution to do, and so anything other than, like, what the operation says is unnecessary.
I understand that. And read directions.
Okay, so moving on. I'm going to go ahead and split this guy up. It doesn't look like I can do a whole lot with this, but we can't have the radical in the denominator. Even if nothing simplifies, the radical in the denominator is not going to work. So I'm going to have to split this up and at least simplify it.
Well,
You got something to say, Kevin? You look. No, I didn't mean that. Yeah. My apologies. That sounded bad. Do you have a question? Kevin, I'm glad you're you, Kevin.
hard today. It's every day. No.
I'm sorry, Kevin. Did you have a question?
No.
That was really bad. That sounded terrible.
Just explain it.
All right, so we're gonna split up the radical.
Not at all. Like you said, good thing I'm me.
It is. It is. All right, so the 12 splits up into 4 and 3. The 4 is a perfect square. Right, and on the bottom, the 5 is still just a square root, so that stays.
Can't be 2, 3. 2 root 3.
It's about 2, right?
Okay. I missed that step.
Yeah, and so remember, the square root of 4 is just 2, so we have 2 roots, 3 on top,
Over root 5.
root 5. But we don't want to leave that root 5 in the denominator, right? We don't like roots in the denominator. That's not considered
Has to get
simplified.
out.
Yeah, so to simplify it, or to rationalize the denominator, we multiply top and bottom by the radical part of the denominator.
Oh, that sucks.
So root 5 times root 5 is equal to 5, and then 2 times 2 roots 3 times roots 5, or root 5 is
15.
2 root 15. And there we go.
Good after grade though.
Yeah, so if you only messed up on that last one, don't give yourself a low score for that, you know, like that's only a third of the problem.
Feel myself. Root 15 and 5. That's 8 points.
Okay, so for 80, I'm just going to take this one from the very beginning, go all the way down to the prime factors, and then circle any pairs, just because I don't see any perfect squares in here yet. So 80, that splits up into 8 and 10, right?
Then
5 times 2 times 4 times 2, which is 5 times 2, 2,
we have a pair.
2 pairs.
4, 2.
Aha,
Check that.
we have 2 pairs.
So that's 16 times 5.
Yeah, we have 2 pairs of 2s, right? And so pairs can be pulled out.
Can you
So-
just can you put root 8 times 10, root 16 times 5, and then 4 root 5?
I don't know. Let's get to that. Hold on. So, okay. So 16 times 5 is equal to 80, right?
Yeah.
16 is our perfect square because that's what all these pairs multiply to, right? So we have 16 times 5, and we break up those roots. Is that what you're asking,
Yes,
Kev? Okay,
yes,
cool.
yes.
Yes, that's exactly what we want to do, right?
4.
Yeah, and we know what the square root of 16 is, so we have 4 roots 5.
Okay, I'm sorry, yeah, that's what I meant.
Let's check our work real quick. Go ahead and tell me, does 4 roots 5 actually equal the square root of 80? That's how we check our work on this. We plug it right in the calculator. So I'm going to say 4 times the square root of 5. Tell me what you guys got.
80.
No, dude. It's the square root of 80. Right? Well, what do you get when you say 4 times the square root of 5?
I brought that here.
Yeah, I want you guys to do this just so you know how to do it on the exam, right? So you're comfortable doing it.
Wait, what do you plug it in?
Here, roll it. Clear.
And so that calculator, you push 4 times,
Oh, clear. 4 times.
and then you'll hit the second button to access the little blue operators.
Times 5.
4 times the square root of 5. What'd you get?
8.944.
Good. Anybody else get that? Yeah? Okay. Now calculate the square root of 80.
Oh, but now.
Is it the same?
Oh, the square root.
Same answer?
I'm getting 100.
I
Whoa.
got 80.
Okay, so check that. So if those two numbers are the same, we got that correct, right? And now you can see on an exam, there's no reason for you to not know whether you're correct or not on these problems. You should absolutely know. Let's get a calculator real quick.
Quit pressing clear.
And what's the square root of 80? Square root. Louis? 1,400.
Okay, so turn it over. Okay, so turn it over. Turn it over.
So I have
It's
this
irrational.
piece of paper at
That's
home
not a perfect
that
square.
has all the square
We were
roots.
really supposed to get there.
And
They just
I
left
don't know
it.
why it's.
No! You can't cheat. That's
You're one of those people.
This one.
it has all the square roots from
I had to be truthful.
the
I
smallest
thought
square
it was a
root,
state actually. And
No,
it's like,
it's
what
not.
is
It's
this?
irrational.
and it has
Now, if you want to calculate the
Now,
square root of
I
5,
was doing that.
okay, now if you want to do that,
And it's 25.
Then it's where it can rational.
so if you want to do that, you have to say 5, take the square
It's
root
not a
of
perfect
5,
square.
and
One
then
is 2.
multiply that.
No, it's one perfect square.
yeah.
Yes.
It's
That's
also
2 points.
irrational.
Don't.
By the same
I
technique
thought
we're
you were
using,
loser.
Right, so if you want to work on
Yeah,
this
1
later,
times 1 is 1.
yeah, we're gonna have to mess with your calculator a little bit, Tessa.
Stabbing head.
And I can let you use mine for the exam if you want,
You
okay?
borrow one from the library.
Yeah, because it's confusing the way that calculator makes you punch it in. Okay, so that's how you check your answers on these, right? And if you remember how to do that, you'll always be confident in the exam that you got the right answer.
Yeah.
It takes like 2 seconds to evaluate those, right? All right, so identify which of these numbers are perfect squares, rational, and irrational. Is this first one, is the number 40, is this a perfect square?
No.
Nope.
No. Is this rational or irrational?
Rational.
Rational, right? Because you can put it as 40 over 1.
That's right.
What about square root 5? Is this a perfect square?
No.
No. Is it rational or irrational?
Irrational.
It's irrational,
Irrational.
right? And it's irrational because this cannot be simplified anymore, right?
Right.
The kind of radicals, if you got a whole number under a radical and it can't be simplified anymore, it's irrational.
No.
What about this first one? Is this a perfect square?
Perfect square. Yes.
Yes. Pa-pow. Is it rational, irrational?
Rational.
Rational, right? Don't let the square root over the 1 fool you, right? This square root of 1 is just equal to 1.
We'll have no trickery here.
Okay, what about this one? Is this a perfect square?
No.
Nope.
No, because it's, you might be able to say maybe if this number up here was a perfect square. Actually, no, you wouldn't, even then.
Nope.
So, no. Is it rational, irrational?
Irrational.
Irrational.
Rational.
No.
This is a fraction that I'm showing you, though.
No, it's not.
Yeah, it is. 17
How
over
is
this.
that not a fraction?
Because that last 8's cut off.
Sorry. Sorry. Kevin.
The 6-3, you're missing a 3 then.
Sure.
Over.
Right, yeah. And so, even if it's this crazy fraction with really ugly numbers, if there's no root or if there's no radical in these numbers, it's rational.
No.
She named wrote big I. You told me it was irrational.
I got it wrong.
All right, how about this first one? Is this a perfect square?
Nope.
No. What about, is it rational? Irrational?
Irrational.
Irrational. Aye.
So I get 9 on that one, bottom line. No. What an awesome class. Look how good class.
Oh, and just to go back, like something that I might mess with you guys on, is this a perfect square?
Yes.
No.
No.
This is equal to 5, and 5 is not a perfect square, right? However, this is a perfect square because this is equal to 9, and 9 is a perfect square, right? You don't think about the radicand if you're thinking about perfect squares. You think about what it equals, right? That would be a fun one to mess with you guys on, so watch out. At least I told you.
No, do not cheat.
All right, guys. So with this one, I ask you to simplify it. And remember, it's not simplified until we rationalize the denominator. So we multiply by the radical part of the denominator. So
By 7, root 7.
yeah, by root 7. No need to multiply by the 5, though, because that's not under the radical. So,
So 2 root 14
Over
5 times 7.
7.
which is 35, so we leave the top up the way it is.
214 over
2 root
35.
14 over
Bam.
35.
good.
We
Excellent.
got that one.
Nailed it.
Oh, yeah.
Okay. All right. So yeah, here's another one. So this is one that includes variables. With variables, there's really some pretty simple rules. We simplify the ones with odd exponents slightly different than we simplify the ones with even exponents. So I'm going to split these guys up. So I'm going to write the root of, and I'm going to swap the order, k to the 8 times z to the 110 times plain old z. All right, and the reason why I did that is because when we're taking square roots, stuff with even exponents is really easy to simplify. Okay, and so I split everything up into even exponents and single factors. Now in this next step, I'm going to simplify everything with even exponents.
So K4.
Right, so k to the 8th. Remember, on an even exponent, it just cuts in half.
But you take away the radical.
Right, and so
So take away the root thing.
the reason for that is because I can write k to the 8th in terms of squares. K to the 4, whoops, squared, not to the 4th.
That's not the 4th.
Thanks. K to the 4th squared, right? And the square root of something squared is just that thing. And so that's why we're cutting these in half. All right, so to simplify the square root of k to the 8th, it just becomes k to the 4th. And the radical goes away.
And then so does the z to the 55th.
Right? Z to the 110, we cut that 110 in half and it turns into z to the 55th
Z.
times
Times
root
That's
z.
it.
Yeah, I know.
Okay, 10 points.
I meant
Treated.
I haven't really.
Okay.
All right, so that's your final answer.
Oddly enough, I think I messed up on it, but I got the same exact answer, but I did not times z by itself inside under the radicand. With the radicand, I actually put a radical over it,
Okay.
and I times it that way.
I don't know if you guys
See,
We'll see is right.
see the little text. Oh, never mind, it disappeared.
oh, that Trek Yak.
Trek.
That's awesome.
Where's that coming
That's
from?
what Spock's little son says. Trek Yak.
Right? That's Klingon? Okay, last one here. So this one involves coefficients and variables. So I handle those separately. I'm going to split this up into the root of 12 times the root of t to the 300. The root 12, that splits up into, root 4 times root 3. And we'll leave this for now until I simplify everything. Okay, so I'm going to simplify this one and bring them out front. The root 4 turns into a 2 because that's what the square root of 4 is. And then we cut our exponent in half to bring it out of the radical. T to the 150.
To the 150 with the 3 remainder.
Right, we couldn't simplify this anymore, so the root 3 just dropped straight down. Okay, give yourselves some scores on that.
I tried.
It's okay. I'm not gonna freak out if, like, I'm just going to be disappointed if you didn't do anything and you give yourself a 10, right? If it's in the extremes, I'm going to be like, oh, come on.
Oh, I did the whole
But if
thing
it's,
down wrong.
yeah, it's fine, yeah. Don't be so, it's okay, guys. I'm not going to attack you. All right. So when you're done with that, please bring it up here and retrieve your next assignment.
Yay.
This one's actually not homework, though. So rest assured. So grab one of these and go and work on it for now. I'm going to go ahead and go over these, and I will give them to you, and you can take off as soon as I'm done with them, okay? And this new one, oh, that's right. Please put your red pens up here, too, so that I don't lose them all. On this assignment that I'm handing out now, I'm going to go ahead and put a video up on the class site that has all the solutions. I'll put it up this weekend so you can check your own work on that. Thank you.
I don't know, this way got so dry.
Do you like WWE? No, that's actually good.
Feel free to talk amongst yourselves and work on that next one together.